Welcome to our live training session. In this tutorial, we're going to be taking a look at how to dial in our idle control and our fuel and spark timing in idle conditions with our MaxxEcu on a Honda K-Series engine. Now, we have a whole bunch of things to talk about here before we actually start to fire up our engine and get it to run. And that's going to be making sure we understand what's going on here and the goal of how to go about dialing in the idle control and the fuel and spark timing. So let's move in here and take a look at our volumetric efficiency table. We're going to start here and just talk about the modifier tables that are in play and understanding when we're getting the engine to fire up and run, what we should or shouldn't do. So let's take a look here. So moving into the main volumetric efficiency table, we can see that's open on my screen right now. I am connected to the MaxxEcu with my laptop. So I'm sitting in the vehicle, ignition key's powered on, the Max is powered on. I'm ready to go in and fire up the engine if I'd like to. So looking at our conditions here, we're going to find in this alpha N strategy using our throttle position as our load input to our VE table here. We can see if I move my foot on the throttle, it's tracking in the table here from 0 to 100%. We're doing the alpha N tuning because we have the Kinsler 64mm throttle bodies fitted to our engine, and therefore we can't get a good map pressure signal, so we're not going to use map pressure as our typical load input to our table. We're going to be using throttle position. This is known as alpha N. So in this situation, we're going to be focusing on our idle area here just to get that worked out. So the goal is to get the engine to crank, fire, and run, and maintain and hold its own stable idle. Now, the next few tutorials, we're going to take a look at doing our part throttle tuning and then take a look at doing our wide open throttle tuning. But this is the very first step of making sure you're getting your engine to actually run properly. So looking here, we're really going to be focused from, let's say, 3% throttle to 0% throttle from roughly 500 to 1500 RPM. This is the area that we have to consider for working with the VE values. And what we're going to specifically find here is that the volumetric efficiency table represents two things. One, the engine being already in its warm state, and two, steady state airflow. So it can compensate and account for those two variables. Warmed up engine, so not when the engine's coming up to operating temperature or cold engine, and then second, steady state airflow. So at idle conditions, we'll be at steady state. Now, why is that important to note and to understand? Well, when we're firing off the engine for the first time, we're going to be dealing with cranking fuel. We might have too little or too much cranking fuel, and we'll talk about that here in a second. That's going to get the engine to crank, fire, and run. But when the engine actually fires off and runs and the engine is cold, we're going to have compensation tables in play that are going to be adding percentage of fuel to whatever is normally calculated from our volumetric efficiency area right here, and that would be for a warm engine. So we're going to have these offsets or multipliers. We have a post-start, known as after start enrichment, as well as a warm-up enrichment. We can actually take a look under our fuel area here so we can unpack this real quick. So under start, warm-up, after start enrichment, the cranking fuel, as I was mentioning before, this is going to be a percentage of multiplier to our normal fueling coming from our VE table. So it's going to multiply the pulse width by this amount under cranking conditions. Now, we've specified anything below 300 RPM for the Max to consider the engine to be in a cranking condition. We can find that up under configurations, engine settings, engine max crank RPM here. So anything below 300, the Max is consider that to be using the cranking table, so cranking spark and cranking fuel. Let's move back in here. So once the engine fires up and it runs, we're going to find that we have an after start enrichment as well as a warm-up enrichment in play. The after start enrichment is used based on engine runtime, also based on coolant temperature. It's going to add a percentage of fuel multiplier to the normal area that we have considering a warm engine condition. So we're cold engine, but it's going to be multiplying against the normal pulse width coming from the area there. And it's going to be doing this temporarily. We can see here at roughly 20 seconds in, the engine runtime. So 0 time is when we're firing off. So we cranked and it started to fire and run above 300 RPM. It'll apply the multiplier here for a brief period of time, then it'll decay away, and then it has no further after start enrichment. This is used to stabilize the combustion to get the engine to fire up and run, make sure it's stable. Now the warm-up enrichment here, this is going to be more of a long-term multiplier or adder against our normal volumetric efficiency table, let's say at idle or part throttle conditions. So we can see this table here is based on coolant temp and a percentage of trim. So both of these are going to be in play when we fire off the engine. Now the engine may fire off and it may be lean, it might be rich. We don't know where it's at. We really want to make sure that the engine can at least fire up and run and maintain somewhat of a reasonable idle, and just wait till the engine comes out of any kind of after start or warm-up enrichment. We can find in this case, that's going to happen here about 140 degrees and warmer. We're going to have no further multiplier or adder against our normal VE table calculation in terms of that representation of airflow. So if we move back in here to our fuel table, We need to wait until 140, 160 degrees when the warm-up enrichment table is completely decayed away, and then we can look at our values here. What we're gonna be doing here and dialing in our idle control. Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.